just the average of your returns. The geometric mean is just the actual growth rate of your returns. Okay. Now with the arithmetic mean, it treats each return as independent from the other years. Okay, so what does we say? It ignores compounding. Also, the geometric mean takes compounding into effect. Okay, each year's return is affected by the previous year's return. Okay, as we said, we're looking for a steady and a smooth growth rate from your beginning amount to your ending amount. Okay, so basically the geometric mean will account for the ups and downs in your returns. Okay, if your return goes up, then goes down, then goes up again, then goes down, the geometric mean is going to try to smooth that so that you can just get a smooth growth rate. So let's look at an example here. Okay, let's say you've invested 100 kwacha. These are your returns for the year. Right, in year 1 you got a return of 6%. Year 2 you got a return of negative 2%. In year 3 you got a return of 15%. In year 4 you get a return of negative 3%. So we have to calculate the geometric and the arithmetic mean. Okay, and we need to basically interpret what they're telling us. Okay, so I've already calculated the geometric mean. Let me just calculate the arithmetic mean. So arithmetic mean, we're just adding up all the returns. 6% plus negative 2% plus 15% plus negative 3%. Okay, so the arithmetic mean is not taking into account that our return dropped, then rose, then dropped again. Okay, it's just treating each year's return as independent. They have no relation to each other. Okay, and then we divide by 4. So 6% plus negative 2%, so 6 minus 2 plus 15 minus 3, we get 16 divided by 4. Our arithmetic mean or our average return is 4%. Okay, so this is our average return, 4%. Okay. Yes. Now we're going to look at the geometric mean, where we're going to now take compounding into effect. We can see here our return first dropped, then grew, then dropped. So we're just trying to ask ourselves, okay, if we try to make a steady growth rate, what is the growth rate that leads us from 6% down to negative 3%? Okay. Maybe let me illustrate this with the. Okay, as you can see, we started at 6%. We go down to. Oops, let's see. Okay, I don't know why my marker isn't working, but yes, we're accounting for the volatility in our returns. It drops, it grows, and it drops. Okay, so this is how you get the geometric mean. This 1 plus R1 multiplied by 1 plus R2 multiplied by 1 plus R3 multiplied by 1 plus R4. This is where we're taking into effect the growth factors of each return. Okay, we want to know, okay, from year 1 to year 2, what was the growth rate? From year 2 to year 3, what was the growth rate? Year 3 to year 4, what was the growth rate? So these percentages, we need to convert them into decimals. Okay, so 6% 0.06, 2% 0.02, 15% 0.15, negative 3%. Remember, it's 1 plus negative 0.03, and it just becomes the same as saying 1 minus 0.03. So notice where the returns are negative in our growth factors, we put them as negative values. Okay, so 1 plus 0.06, 1.06, 1 minus 0.02, 0.98, 1 plus 0.15, 1.15, 1 minus 0.03, 0.97. Oh, and here it's to the power 1 over n. N is just the number of years, which is 4 years. Okay, so when we multiply these numbers, we get 1.15878 to the power 1 over 4. In your calculators, you can put this number to the power 0.25 and you get 1.0375. Okay, and then we subtract this from 1, we get 0.0375. So our geometric mean is 3.75%. So basically, it's like the growth rate of our returns is 3.75% per year. That's like the growth rate. Okay, to take us from 6% to negative 3%. Okay, now remember, the positive returns outweigh the negative returns. So don't think that because we're ending, our last return was negative 3%, so it means that we ended up on a bad number. No, we're just accounting for the change in the percentages. Okay, we're accounting for that, and we're just trying to just get a single number that can represent an average growth rate for our returns. So on average, our returns grew by 3.75%. So let me just illustrate this with this example here. Okay. So for example, as we said, if we started with 100 kwacha, all right. Remember, in the first year your return is 6%. So 100 multiplied by 1 plus 0.06, our return was 106 kwacha. In year 2, there was a percentage drop of 2%, so saying 106 multiplied by 1 minus 0.02, we get 0.98. 106 times 0.98, 103.88. Then there was a growth of 15%, so we say 103.88 multiplied by 1.15, 119.46. Okay. Then 119.46, there was a drop in the growth rate of 3%, so 1 minus 0.03, you get 0.97. 119.46 multiplied by 0.97, we get 115 kwacha. I want to read dollars here. 115 kwacha, 87 ingwe basically, or 88 ingwe. Okay. So basically, our geometric mean is 3.75%. So we're saying from 100 kwacha, we had a steady growth rate of 3.75%. That brought us from 100 kwacha to 115.88. Okay, because as I said, the geometric mean is showing you the average growth rate, which is going to take you from your beginning amount, which is 100 kwacha, to your ending amount, 115.88. Okay, so we can prove this. Okay, remember our growth rate. Okay, no, here's the 375. Okay, our growth rate 3.74% each year. So we're going to say 100 multiplied by 1 plus the growth rate to the power n. Okay, number of years. Okay, so our growth rate, as we said, it's 0.0375. This is our growth rate. You add it plus 1.0375. 1.0375 to the power 4, since it's 4 years. So 1.0375 to the power 4, we get 1.158 multiplied by 100, we get 115.86, which is similar to 115.88. So basically that's what the geometric mean is. It's just giving you an average growth rate, which is showing you how your money changed from its initial value to its end value. Okay, so this average growth rate of 3.75% we started with the 100 kwacha and we ended up with a 115.88 kwacha. So just remember that the geometric mean is just giving you your average annual growth rate for your returns, and the arithmetic mean is just giving you the average of your returns or your typical yearly return.